Hey everybody, and welcome to this video dealing with today's topic of squares and square roots. So let's go ahead and let's get started. I'm going to start out by writing what 1 squared means, 2 squared means, 3 squared, 4 squared, and then we're going to go through how to calculate the square root. So if I start with 1 squared, well, what that means is 1 times 1. And 1 times 1 equals 1. Okay, so 1 squared equals 1. So what can we say about this? Well, let's rewrite this 1 squared equals to 1. And now what we're going to do is take the square root of both sides. And now what we get is the square root sign cancels out the exponent 2, and that leaves you just 1. So 1 equals the square root of 1. Or we could say the square root of 1 equals 1. So what the question that we're answering here is, what one number was multiplied by itself twice to get this number? Well, here's the number that was multiplied by itself twice, which is 1. This number was multiplied twice to get that number. Sorry, pointing to the wrong one. 1. Okay, let's try it again with 2 squared. 2 squared means 2 times 2. And 2 times 2 equals 4. So now the square root of 4, what that means is what one number that I multiply twice to get the number 4. Oh, is the number 2. 2 is the one number I multiplied twice to get the number under the radical. So the square root of 4 is 2. We'll keep going. 3 squared means 3 times 3, and 3 times 3 equals 9. Therefore, the square root of 9 equals 3. 4 squared means 4 times 4, which equals 16. So now the square root of 16 equals 4. And we'll keep going. 5 squared means 5 times 5, which equals 25. So the square root of 25 equals 5. 6 squared means 6 times 6, so that equals 36. So then the square root of 36 equals 6. 7 squared means 7 times 7, which is 49. So now the square root of 49 equals 7. We're going to erase this and continue with 8 squared, 9 squared, 10 squared, until we get to probably 13. Okay, picking up with 8 squared, which means 8 times 8, which equals 64. So now the square root of 64 equals 8. 9 squared means 9 times 9, which is 81. So the square root of 81 equals 9. 10 squared means 10 times 10, which is 100. And so the square root of 100 is 10. 11 squared means 11 times 11, which equals 121. So the square root of 121 equals 11. 12 squared equals 144. So the square root of 144 equals 12. And last, 13 squared is 169. And the square root of 169, that equals 13. Hope that makes sense. Hope that's clear, because we're going to be using these square roots when we introduce a future topic of Pythagorean theorem. You may have heard that stuff before, but we're going to be using squares, taking square roots. So it's going to be important to know that square root of 64 equals 8, square root of 81 equals 9, square root of 100 is 10, all the way down to square root of 169 is 13. And we'll be taking square roots of other numbers. But I wanted to go through this video to help you understand what does squared mean. And squared means, for example, when I point to 13 squared, that means 13 times 13. And then that equals 169. Now, when I look at the square root of 169, I know that that equals 13, because the question, again, I want to reemphasize, what question are we asking here? The question we're asking here, when I see a square root and a number, I'm asking, what one number did I multiply by itself twice to get 169? In this case, the answer is 13. The square root of 144, the question I'm asking is, what one number did I multiply by itself twice to give 144? The answer is 12. All the way up to square root of 64. The question that we're asking is, what one number did we multiply by itself twice to get the number 64? Well, the answer is the number 8. And if you need to take your time and rewind this back a little bit to take a look and review some things, please do so. Okay, so with that said, we're going to move now to Pythagorean theorem. It sounds worse than what it actually is. Okay? All right. Well, Pythagorean theorem starts out, have a triangle. Actually, you have a right triangle. And I know it's a right triangle because I'll have this symbol usually right there. The little square means it's a right triangle, which means that angle equals 90 degrees. But here's the key thing about Pythagorean theorem, right up here, Pythagorean theorem, Pythagorean theorem. With the triangle, tri means 3, so we have 3 parts to a triangle. You have this longest side here, and we want to call that side C. Then we have 2 legs. This leg here, let's just call this A. And then this side, we're going to call this B. I could have easily had this labeled A and this labeled B. But what's important is we have the longest side of the triangle labeled as C, and that's called your hypotenuse. I'll get some vocabulary for you. Hypotenuse. So when you hear the word hypotenuse, know that it means the longest side of the triangle. Okay, so the Pythagorean theorem, it means I'm going to add some squares to these A, B's, and C's that you see. So I'm going to have C squared, A squared, and B squared. So I'm going to have C squared equals to A squared plus B squared. Actually, for a second, let's take those squares off of the diagram. Yeah, just leave it as one leg of the triangle or one side of the triangle, which is A. Another side of the triangle is B. And the longest side of the triangle is C, which is called our hypotenuse. Now, in the problems that you're going to face, you're going to be given 2 of the 3 values. So for example, if you're given that A is equal to 3, all right, that's A equals to 3. And then suppose you're given that B is equal to 4. Now we need to solve for C. Since we know this is a right triangle, we can use our Pythagorean theorem here to solve for C. How do we do that? We're going to plug in the values for A and B into our formula, and then solve for C. So now I have C squared, because I don't know what C equals, but I know that A is going to be equal to 3. So I substitute 3 for A. It's going to give me 3 squared. And then plus B. Well, we know B equals 4. So substituting 4 for B gives me 4 squared. Okay, on our next line, bring down our C squared. And that's going to equal 3 squared, which is 9, because 3 squared means 3 times 3. And we know that 3 times 3 equals 9. Bring down our plus sign. And next we have 4 squared, which is 4 times 4, which is 16. Okay, on our next line, bring down our C squared. And that's equal to 9 plus 16, which equals 25. Now, to solve for C, to get C by itself, we're going to take the square root of both sides. Square root of C squared equals square root of 25. And now for lack of a better term, the square root sign and the square cancel each other out, leaving us just C. And now that equals, well, square root of 25. Again, we ask ourselves, you know the answer is 5 right offhand, but just in case, you say to yourself, okay, what one number do I multiply twice to get 25? Well, that number is 5. And this is why it's important to know your square roots. So now we know that the value C is equal to 5. You know, but let's work one more problem. And this time, we're going to be given the hypotenuse and one of the sides, and we'll have to solve for the other side. So you ready to draw my right triangle? This time I'm going to have my hypotenuse C is going to be 5. One of my legs, I'm not going to know, so I'm just going to call that A. And my other leg, which is B, let's see, we're going to give that a value of, I don't want to do, okay, that'll do the same thing. Whoops. Let's change C to 12 and let B equal to 10. Now, we're going to write down Pythagorean theorem. C squared equals a squared plus b squared. And now we're going to substitute in the values for c and b in order to solve for a. So I know that c equals 12 and b equals 10. So I'm going to put those values in this equation. So I have 12 squared equals a squared plus b equals 10. So 10 squared. Now, 12 squared means 12 times 12, which equals 144. Now that equals, bring down my a squared, and now plus 10 squared, which is means 10 times 10, which equals 100. Now to get a squared by itself, I need to subtract 100 from both sides. I'm subtracting because I have a plus sign right here, which means addition. So to get 100 to the other side, I need to do the opposite of addition, which is subtraction. So I'm going to subtract 100 from both sides. Okay, so 144 minus 100 equals 44. Now that equals, bring down my a squared, and 100 minus 100 equals 0. So now to get uh, a by itself, we're going to take the square root of both sides. Square root of 44 equals the square root of a squared. And as we just said, when you take the square root of the square, well, the square root sign and the 2 cancel each other out. Might be hard to think, wow, how can a sign or a symbol cancel out a number? Well, that's a whole different discussion. But trust me, it works. The square root of a squared, believe me, just a. And now on the left side, I have square root of 44. Now that can be simplified more. So I'm going to write, up here I'm going to write a equals square root of 44. Well, doesn't 44 equal 11 times 4? Well, let's write it like that. I've rewritten this as a equals the square root of 4 times 11. Now just rewriting this, I can write this as I can rewrite this as a equals the square root of 4 times the square root of 11. All I did was put I broke up this square root of 4 times 11 by placing the 4 under its own square root sign and put the 11 under its own square root sign. I did that because I know what the square root of 4 is. The square root of 4 is 2. Therefore, A is going to equal, the square root of 4 is 2. And I'll leave the square root of 11 as is. So therefore, A is going to equal 2 times the square root of 11. Yes, numbers can get messy. Sometimes it's not always nice whole numbers, but this is our final answer for this right triangle where we had a hypotenuse where C equals to 12. We had one side, B equal to 10, and we found out that the other side, A, was equal to 2 times the square root of 11, all by using this Pythagorean theorem. Okay, that's it for this video. We walked through squares, square root, and Pythagorean theorem. Again, I hope you understand. If you need to rewind and watch a little bit of this again, please do so. Take your time. Make sure you understand what you're doing. Thanks a lot. Take care. Talk to you soon.